Two far-flung comets are visiting Earth just in time for Halloween, James Ray from The Conversation reports. The human mind may find it difficult to conceptualize a cosmic cloud so colossal it surrounds the Sun and 8 planets as it extends trillions of miles into deep space. A spherical shell known as the Oort cloud is, for all practical purposes, invisible. Its constituent particles are spread so thinly and so far from the light of any star, including the Sun, that astronomers simply cannot see the cloud, even though it envelops us like a blanket. It's also theoretical. Astronomers infer the Oort cloud is there because it's the only logical explanation for the arrival of a certain class of comets that sporadically visit our solar system. The cloud, it turns out, is basically a gigantic reservoir that may hold billions of icy celestial bodies. 2 of those bodies will pass by Earth in the days leading up to Halloween. Tucson Atlas, also known as Comet C 2023A3, which was discovered last year, will be at its brightest and likely visible to the naked eye for a week or two after today, the day before yesterday, October 12th, the day it's closest to Earth. Just look to the western sky shortly after sunset. As the days pass, the comet will get fainter and move to a higher part of the sky. The second comet, C 2024 S1 Atlas, which was discovered this year, just discovered September 27, should be visible around the end of October. The comet will pass closest to Earth October 24, look low to the eastern sky just before sunrise. Then, after swinging around the Sun, the comet may reappear in the western night sky around Halloween. It's possible, however, that it could disintegrate in part or in whole, as sometimes happens when comets pass by the Sun, and this one will come within 1 million miles, or 1.6 million kilometers of our Sun. As a planetary astronomer, the author says, I'm particularly curious about the Oort cloud and icy bodies inhabiting it. The cloud's residence may be a reason why life ignited on Earth, crashing on our planet eons ago. These icy bodies may have supplied at least some of the water that all life requires. At the same time, these same objects pose an ever-present threat for Earth's continuation and our survival. In the event, of course, of an impact, billions of comets. If an Oort cloud object finds its way to the inner solar system, its ice vaporizes. That process produces a tail of debris that becomes visible as a comet. Some of these bodies, known as the long-period comets, have orbits of hundreds, thousands, or even millions of years, like the Tucson Atlas. This is unlike the so-called short-period comets, which do not visit the Oort cloud and have comparatively quick orbits. Halley's Comet, which cuts a path through the solar system and orbits the Sun every 76 years or so, is one of them. The 20th century Dutch astronomer Jan Oort, intrigued by the long-period comets, wrote a paper on them in 1950. He noted about 20 of the comets had an average distance from the Sun that was more than 10,000 astronomical units. We know 1 astronomical unit is the distance between the Sun and Earth, which is about 93 million miles. So these are 10,000 astronomical units. This was astonishing. Just 1 AU is the distance from the Earth from the Sun, which is about 93 million miles. Multiply 93 million by 10,000, you'll find these comets come from over 1 trillion miles away. And what's more, Oort suggests that they were not necessarily the cloud's outermost objects. Nearly 75 years after Oort's paper, astronomers still can't directly image this part of space. But they do estimate the Oort cloud spans up to 10 trillion miles from the Sun, which is almost halfway to Proxima Centauri, the next closest star. Halfway. The long-period comets spend most of their time at those vast distances, making only brief and rapid visits close to the Sun as they come in from all directions. Oort speculated the cloud contained 100 billion of these icy objects. that may be as numerous as the number of stars in our galaxy. How did they get there? Oort suggested the modern simulations have confirmed that these icy bodies could have initially formed near Jupiter, the solar system's largest planet. Perhaps these objects had their orbits around the Sun, disturbed by Jupiter, similar to how NASA spacecraft bound for destinations from Saturn to Pluto have typically swung by the giant planet to accelerate their journeys outward. Some of these objects would have escaped the solar system permanently, becoming interstellar objects, but others would have ended up with orbits like those of the long-period comets. Threats to Earth? Long-period comets present a particular potential danger to Earth because they are so far from our Sun. Their orbits are readily altered by the gravity of other stars. That means scientists have no idea when or where one will appear until it does, suddenly. By then, it's typically closer than Jupiter and moving rapidly at tens of thousands of miles an hour. Indeed, the fictional comet that doomed Earth in the film Don't Look Up came from the Oort cloud. New Oort cloud comets are discovered all the time, a dozen or so per year in recent years. The odds of any of them colliding with Earth are extremely low, but it is possible. The recent success of NASA's DART mission, which altered the orbit of a small asteroid, demonstrates one plausible approach to fending off these small bodies, but that mission was developed after years of studying its target. A comet from the Oort cloud may not offer that much time, maybe just months, weeks, or even days, or no time at all. Oumuamua, the interstellar object, the odd little object that visited our solar system in 2017, was discovered not before but after its closest approach to Earth. Although Oumuamua is an interstellar object and not from the Oort cloud, the proposition still applies. One of these objects could sneak up on us and the Earth would be defenseless. One way to prepare for these objects is to better understand their basic properties, including their size and composition. Towards this end, my colleagues and I work to characterize new long-period comets. The largest known one, Bernardinelli Bernstein, discovered just 3 years ago, is roughly 75 miles across, 120 kilometers, which is huge, of course. Most known comets are much smaller, from 1 to a few miles, and some smaller ones are too faint for us to see. But newer telescopes are helping, in particular the Rubin Observatory's decade-long legacy survey of space and time, which will start up next year in 2025, may double the list of known Oort cloud comets, which now stands at about 4,500. The unpredictability of these objects make them a challenging target for spacecraft, but the European Space Agency, ESA, is preparing a mission to do just that, Comet Interceptor. With a launch planned for 2029, the probe will park in the space until a suitable target for the Oort cloud appears, and studying one of these ancient pristine objects could offer scientists clues about the origins of the solar system. As for the comets now in Earth's vicinity, it's okay to look up. Unlike the comet in DiCaprio movie, these two will not crash into the Earth. The nearest Tungsten Atlas will get to us is about 44 million miles. See 2024 SA Atlas, about 80 million miles. Sounds like a long way, but in space, that's a near miss. This is by James Ray, Professor of Earth and Atmospheric Sciences, Georgia Institute of Technology, on Space Alert. Please leave your comments. Thank you for your support. Support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.